How are you, everyone? Tired? Let me actually start by showing a calculator. I'm going to post it on Brightspace. So anytime you need to know how much you need to get in your next 3 exams to pass this class, or how much you can improve your My MATLAB assignment, you can find that by yourself. So you already have your 3 exam score. You put them in exam 1, 2, 3. The quiz and homework. The quiz is supposed to have total 290 points, and homework is supposed to be total 410 points. You can get them from Brightspace, or you can get them from your My MATLAB. So get the points, put it there, put your exam score there, and then it will tell you how much you need to, it will tell you what would be your average overall score under the green one. Ignore the yellow one. Yellow one, I supposed to submit in the department. So let's say I have a student who attended every day. So has 36 points. Let's say did all the quizzes, but having 100% in the quiz is kind of bad. Not possible. And then let's say did all homework with 100% points. And let's say the exam scores are bad. For example, these are the exam scores, or probably let's say 30, 49, 60, let's say got 50 here, and the final exam you have to have 50. See, this person still failed because the average came out to 57. The average has to be at least 60 to pass this class. So if your My MATLAB quiz is not that good, it is good, but it's not more 290. And you have all in-class exam kind of failing, you cannot pass this course.
Is the fifth exam the final exam?
Huh?
Is the fifth exam the final exam?
No. We have 4th and 5th in-class exam and final exam. So get 3 more in-class exam. So 3 more total exam. So you can play with that. Now let's say, what if you improve your score to 210, 250? So it becomes 58, means closer to 60. Maybe you can improve your exam 5th score, let's say 55. See, it got better. And let's say instead of 55, you get 56. You still don't pass. Let's say you have 58. No, 60. Still not possible. So let's say you get 51 in the final exam. Only then you pass. So you can play with a calculator with these 3 numbers. So 1, 2, 3 are fixed. You already have your scores. But 4, 5, and final exam, these are changeable. So you can play with those scores, and you can play with the My MATLAB scores, and you can figure out whether we have a chance of passing this class or not having a chance of passing this class. Question, what is that?
Were you gonna drop any of the lowest scores that you have?
It's not me, it's the Department of Policy. We're supposed to give you 5 exams, everything included. All of them are total 50%. So I'm going to post this on Brightspace. Play with that before the. Yeah. Oh, the thing is, you need the Excel app to play with the sheet. Play with the sheet. You get to MyMathLab. So let's go to MyMathLab. Da, 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 da. Where is MyMathLab? Here. So you go to Brightspace. You go to your class and see on the homework. Either you can get it from your gradebook, I think from Brightspace. I actually go to MyMathLab directly to get your score. Da, 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 da. Man, it takes forever. Is MyMathLab not working at this moment? It's working? Then how come I can't log in? Homework. Go to MyMathLab. For some reason, it's not letting me to open. Let me see if I can log in from. Not from. Let's see if I can log in from here. Oh, it came. Just. So you have your grade book, right? Do you have a student view here? No. When you go to your grade book, you can see your score. Who want me to show you score? Okay, Yvette. Mm-hmm. Yvette, okay. So I don't know how do you see them, but for my case, I just click on the overall score. Oh, see, you have the same thing. So click on the overall score. Oh, it's too. Let me make it bigger. So you click on see overall score is hidden. So you have to click it to show, and then go to the calculation. It tells you how much you have out of how many points. So our the semester you took complete 110 and 290 points. And currently you have 179 and 99. So you get those 2 points and put them on the Excel calculator here, and then it will calculate the overall grade if you put the rest of the information. Majority of what? So let's see, Kimelsia, what do you have? Kimelsia. So 410, out of 410, you have 227, and 290, you have 134. So you're improving. You have a decent amount of score, but your goal should be 410 here, and then at least about 200 here. The more you have here, that means the less you can have in your exam. Okay, so get the score from here, put them on the Excel file, play with it, and see what do you need in exam 3, 4, exam 4, 5, and final in order to have your desired grade. And if you see there is no way you can pass, then you should drop and retake it later. And let's say you're taking it for the 3rd time. If you're taking it for the 3rd time and then there's no way you can pass, you have 2 choices, I think. Choice number 1, change your measure to something that doesn't require this class. Like communication. I think communication doesn't require this class. So change your major to that. Or get out of the Baruch for 1 semester, do class in some other institute, and come back again. So they will kick you out for 1 semester, but then you can resubmit. I think. Re-enroll. Let me actually post it now before I forget. So I'm posting this calculator on my MATLAB, sorry, on Brightspace. Content. Grade calculation calculator. And let me put it on the top. Okay, so it's on Brightspace. The numbers you see, those are usually numbers, okay? You have to change every number with your information. Like here, currently you see something different, like something like these weird numbers. So change everything what you have, and then how much you think you can have in exam 4, 5, and 6. And then it will tell you. Look at the green one, not the yellow one. Because green one is the overall, and yellow is before final. Okay, before we start, any other question from anyone? So if you didn't do my MATLAB homework quizzes, I'm telling you again, without them, there is no way you can pass this class. Especially if your exam scores are bad. And there is no way you can get A in this class or B in this class without them. If you're looking for A or B in this class. So you do need them. Plus, the attendance was a heavy weight. Play with the attendance. Total, you can have 36 days. And the attendance you see on the picture I sent you, it was based on 21 days. Because you're missing 2 classes. So total, we have 42 days. I'm disregarding 6 days. In these 6 days, you have 4 excused absences and 2 free absences. Okay. So entire semester, you're allowed to be absent for 6, and then every absent counts. Before spring break. It's an 11. Yes, sir. 11th out. 3 weeks. So 11 is 2 weeks, and then we have this week, so 3 weeks. Yeah. So our next exam will be just before the spring break, and another one will be on May, and then you finalize them is May 20, I think. Any other question before you start? Oh, one more thing. In our next class, there will be someone from the department. They will come here to observe you guys. So make sure you come before class. Okay? Come earlier than class starts. May 20, if I'm not wrong. 8 a.m. in the morning, May 20. It's a departmental policy. I also need to know, like, why? Why do you have to be 8 a.m. here? I hate that. But yeah, I can change anything. Okay, guys, remember, class day, definitely don't be late. Come early. We are going to have a guest to observe us. He will observe, he will comment, not verbally, but he's going to write a report on us. Okay? So be extra nice, extra good on Thursday. Any question before we start? Comments, concern, complaint? No? So we did section 7.1, 7.2, where we learned about simplifying rational, finding domain of the rational, multiply and divide. 7.3. So today you're studying 7.3 and 4. It talks about addition and subtraction of rational, which is little bit more work than multiplication and division. Before we add and subtract, there is one condition. We have to have the same denominator. If the denominators are not same, we cannot add or subtract. So in order to guarantee you have to the same denominator, we use the help of equivalent expression. Equivalent expression means two expressions, they look completely different, but actually they are the same thing. They're same, they just look different. Now we can have equivalent expression by only either multiplying or dividing. Usually we multiply, we don't divide. We divide only when we already given the bigger one and we want to make it smaller. Otherwise, we always multiply our given expression by something so that we can get an equivalent expression. So, for example, here, if we have 3/5, it's same as what over 10? 6 over 10. How do you need 6 over 10? What did you do? Multiply by 2. So you observe the given information. We have 5 and 10 on the denominator. To go from 5 to 10, we just to multiply 5 by 2, we get 10. Now, since we multiply 5 by 2, you need to multiply the numerator by 2 also to have the equivalent expression. So equivalent expression has the same thing, just multiply by same number on the numerator and denominator. How about the second one? We just square. We only multiply. So we have 1 over a. Our goal is to convert this a into a square. So we need to multiply by another a. So we multiply top and bottom by the same thing. So what goes on the top then? A. So 1 over a is same as a over a squared. They're equivalent. See, we have a, we are going to a to the 4th. What can we multiply these to turn into a to the 4th? A to the 3rd. We need 3 more. So 1 here, we need 3 more, then we have 4 of them. That means you have to multiply the denominator by the same thing. So we get a cube b. So a over b is same as a to the 4 over a cube b. Clear? Any questions so far? Now, how about this one? We are given 13 over 5a squared. We want to rewrite this as 10a squared b. So we need to multiply the denominator by what to convert 5 to 10 and a squared to a squared b?
By 2.
You can only multiply by 2. And how about the variable? We have a squared, but here we have an extra variable. So you have to multiply by b. Anytime you multiply numerator or denominator, you have to multiply the other one. That's the rule because you have to cancel. I mean, now you don't have to cancel that. It's like if you cancel them, you're not doing anything. So what goes on the numerator then? 2060. The 13 over 5a squared is same as 26b over 10a squared b. Why do you care? Because to add or subtract, we have to convert one new denominator into different denominator. And the different denominator will be the LCD. So to convert even denominator into LCD, you have to multiply top and bottom by something to have the equivalent expression. That's the goal. Now, one last question. So how can you change this denominator into the right denominator? Times 2. But if you do it on the bottom, you must do it also on the top. That means what do we have at the end on the top? Negative 2y plus 26. Two times 35x squared is 70x squared. 2 times 20 is 40. So if you multiply this by 2, it becomes our right denominator. So is the concept clear about equivalent expression? Is anybody lost yet? No?
So we're multiplying everything, I didn't only my savings. 35 and 70, so why is it x squared? 2x squared.
Let's say you have 3x and you're multiplying these two. What do you get? So why didn't I write 6 and then 2x? See? Same reason. When you multiply, only multiply the numbers. Okay, since you understood the equivalent expression, that means you're ready to do some math. Can I change my slide? I have to change 3 slides. So can I guess done with everything? Okay. Now ignore all the details here. And let's come here. Do the actual addition subtraction. When you do addition, subtraction, or fraction, there are 2 scenarios. Either we have the same denominator or we don't have the same denominator. If you do have the same denominators, your life is easy. Because all you have to do is keep the denominator, combine the top. That's all you have to do. Problem comes when you don't have the same denominator. That times we need the equivalent expression to have the same denominator. And when you have the same denominator, you just add the top and simplify. So here, do you have the same denominator? Yes. So we are going to keep the denominator once and do the operation. 2 plus 5, so we get 7/3. Because same denominator. But that's how we add numbers. We do the same thing when we add expressions, rational expressions. Do you have the same denominator? So keep it denominator. And whatever we have on both numerators, put them together, combine them. So x plus 3 plus x minus 1. Oh, I should make it a little smaller. When you put the numerators together, what do you have? Minus. Sorry. I definitely hope faster to make me take mistakes. 2x plus 2. But we cannot stop here. Why can't we stop here? Leandra. Because we can factor. Anytime it's factorable, always factor. So how do you factor here? GCF or perfect square? Which one? GCF. So what is your GCF? 2. X plus 1. And then x minus 5. Can you cancel x plus 1 and x minus 5? So leave them alone. Any question? No, because even if you do, it doesn't help us. If factor out -1 or something like this, let's see x minus 5 on the bottom and 5 minus x on the top. See, 5 and x, they're same, just their signs are different, then you can factor out and cancel. But here you have x plus 1, x minus 1, they're completely unrelated. So you cannot do them. Now let's do on subtraction. Do you have same denominators or different denominators? Same. So we write the denominator once and we combine all the numerators. Emulsia. Huh? X plus x, p minus 1. So combined like terms. So we have 4x squared plus 15x, and you're subtracting 8x plus 15. Did I write it correctly or did I make a mistake anywhere? Looks correct, right? But it's not correct. Anytime you subtract more than one term, you have to put parentheses because the sign will change for the second polynomial. So you have two choices. Either write this way or change your sign here. Okay? But you have to change your sign somewhere on the top or on this tab. It's up to you.
So it has to be outside of parentheses when you rewrite it?
Exactly. Because you're subtracting our second numerator. What is the second numerator? That goes inside the parentheses. So we have x plus 3, 4x squared plus 15x minus 8x. And is it plus 15 or minus 15? Minus 15. It's a common mistake. People don't put parentheses, they don't change sign. If you don't put parentheses, you must change sign here. Like this one. Subtract 8x and also subtracting the 15. Do we have any like terms to combine? 15 and 8. That gives us how much? Positive or negative? 6?
7.
7. Positive 7x minus 15. So we cannot stop here because now we need to check, is the numerator factorable? Let me do the shortcut AC. So this is A, this is C, AC 4 times negative 15. What is 4 times negative 15? 60. Can you find two numbers multiplied to negative 60 combined to 7? Negative 60. It's negative 15. 6 and 10 doesn't give you 7.
Oh.
12 and 5. But how about the signs? 12 has to be positive because the middle sign is positive. The bigger factor always gets the middle sign. That means 5 has to have what sign? Negative. And then you can find the factor in just 2 lines. We have, it's too small. Let me write a little bit bigger. We have plus 12 and minus 5. I'm doing shortcut, okay? If you want to do long way, go ahead, but I don't have time, so let me do shortcut. If you do shortcut, you place them into two parentheses, and then you write 4x on both. But then you factor out whichever factor is factorable. Is this factorable 4x minus 5? No. 4x plus 12, is this factorable?
Yeah.
You can factor what out? Can you factor more than 4? So you factor out 4 and you get what? X plus 3 and ignore your 4. Do it mentally. Yeah, 4x minus 5. That's it. These are the two factors you have. So do the factoring mentally, ignore the number, and that's the factors.
So I forgot about it, and I did like times back to 7 and the 5. That's so good.
Then you replace, if you're using normalizing method, you replace 7x with 12x and 5x. Yeah. And then you use grouping method. So let's do it on the next. We're not done. I need more space, so let me get a page. So we have x plus 3 on the bottom, and the two factors by using SC method is x plus 3 and 4x minus 5. You get the same thing, right? What do you observe? Do you observe anything here? We can cancel out the x plus 3. So what is left? On the top or on the bottom? Top. 4x minus 5. So same denominator means write the denominator once, combine the top, factor, which cancel or cancel, which not, keep it. Any question? The last one, you try it. Same denominator is too easy, so most likely you're not going to see any same denominator question in the final exam. But definitely one will be from addition subtraction. Yes. So do we add 6 or do we subtract 6? Add. Good. So the sign will change for both of them on the numerator. Do you see any like terms? Leandra. X plus 8. You mean you're factoring, right? X plus 5, x plus 8. X plus 8 is on the top, x plus 8 is on the bottom. We have x plus 5 left, but it's on the denominator. What goes in the numerator then? 1. In multiplication division, we left it 1 if you don't see anything. In addition and subtraction, we left it 0 if you don't see anything. Any question? Go ahead. Is this factorable? Oh, 6x minus 5x. What do you have? So you combine these, and then you combine these. No. First you have to combine, and then you factor. Combine like terms. So you always have to combine like terms before you go factoring. Combine like terms, and then based on the final version, you factor. Huh? If it's GCF, you can factor out. If it's factorable directly, you factor directly. Or if you choose SE method, you choose SE method. If it's not factorable, leave them alone. So when you have same denominator, life is easy. That's how you do. problem starts when you don't have the same denominator. When you don't have the same denominator, we look for LCD, which is called least common denominator. So in order to find LCD, we look for multiples. LCD has another name, LCM. It means least common multiple. Multiple means the result, the product of whatever you're multiplying. To find LCD, you look for whether they have some relationship or they don't. If can you multiply, is one number is multiple to the another one? If not, then you multiply them to get the LCD. And if one number is multiple to the other one, then you take the multiple one, the bigger one. For example, 2 and 3. Is 3 a multiples of 2? Like, can you multiply 2 by something and get 3? No. That means the LCD is their product, 6. Oops. So 2 and 3, they are not multiple of one another. So we multiply them, we get the result. Between 3 and 4, is 4 a multiples of 2? So what is the LCD between 2 and 4? 4. So if you already have a multiple, that's the answer. If you don't have a multiple, you multiply them. How about if I put them together, 2, 3, and 4? How did you find its real?
First one, they all. First number.
So you compare 2 and 4. 4 is a multiples of 2. That means you don't have to count 2. You ignore that. And then you observe 3 and 4. Is 3 and 4 multiple of one another? So their LCD is 3 times 4. 12. That's how you can find multiples or LCD. Compare them if they are same numbers, like same odd or same even. And then if they have nothing in common, you multiply them. How about 3, 4, and 5? Is any of them a multiple of other one? Is 4 a multiples of 3? Is 5 a multiples of 3? Can you multiply 3 by something to get 5? Is 5 a multiples of 4? So none of them are multiples of one another. So what is the LCD? You multiply all 3. 4 times 5 is 20. 20 times 3 is 60. So our answer is 60. And that's how we find the multiples of numbers. Now comes variable. Remember when we did factoring, I showed you we take GCF, it's the factor that is common in all 3 terms. For multiples, it's the other way around. You look for something big, the big thing is divisible by all 3 of them. So between x squared, and x cubed, big is x cubed, the biggest one. So LCD should be x cubed. Because you can divide x cubed by x, you get a perfect square. If you divide x cubed by x squared, you get a perfect x. If you divide x cubed by x cubed, you get a perfect number 1. So see, x cubed is divisible by x squared, x cubed, all of them. And you get something whole, not a fraction. So LCD is the bigger power, not the smaller one. Factor is the smaller one, the smallest one. LCD is the biggest one. How about the LCD between x and y? Is y a multiples of x? Is x a multiples of y? So when you don't have multiples of one another, what do? You multiply them. xy. See, x squared is a multiples of x, so we disregard x, we get x squared. But x cubed is a multiples of x squared, so you disregard x squared and then get x cubed. So if you have something multiples of another thing, you take the bigger one, the multiple one. But between x and y, they are not multiple of one another, so you multiply them. How about x squared, y squared? X squared times y squared. So you compare these, you get x squared. You compare these, you get y squared. Now between x squared and y squared, they have nothing in common, so you multiply them both. Clear now? How do you find LCD?
So you multiply those two, like x times x.
Not multiply it, compare it. Between x and x squared, which one is bigger?
X squared.
Between y and y squared, which one is bigger?
Y squared.
Because they are multiples of one another, so you took the bigger one.
So you're kind of looking at the biggest LCD.
Biggest power. Eric. 60. Between 3 and 4, do they have anything common? Is 4 a multiples of 3?
No.
No. Now you compare 3 and 5. Is 5 a multiples of 3? Then can you multiply 3 by some number to get 5? Now between 4 and 5, can you multiply 4 by something to get 5? That means all three, they have nothing connected. Somehow they are not connected. So when you have something they're not connected at all, you multiply all of them. And that's how we got 6 from 3 and 3 because they are unrelated. And now let's say we are mixing them up, number and variable. What is the LCD between 3 and x? 3x. Because they have no connection between them, no relation between them. The next one? 12xy. Now, very interesting. X and x plus 2. Can you multiply x by something and get x plus 2? So do they have any connection? Any relation? So when you don't have anything unrelated, what do? You multiply them. So it's x and x plus 2, both of them. For LCD, we never add or subtract. We always multiply. How about x plus y and x minus y? Can you multiply x plus y by something and it will turn into x minus y? Is it possible? No. So you take both of them. X plus y, x minus y. Because you cannot multiply one by something to get the other one. And now the last one.
X plus 2, but when you say multiply, so that's like as much as
So when you multiply, you get x squared plus 2x. But the question I asked is, can you multiply x by something and it will turn into x plus 2? No. That's why the LCD is the product. And now in product, you can distribute, but you don't have to. Because our goal is to cancel them with the numerator. So what's the answer with the last one? So we have x plus y. How many of them here?
One.
One of them. And you have the same thing. How many of them here? So what's the LCD? 2 of them, not 3. 2 of them, the bigger one. X plus y, the bigger power. It's just like between x and x squared. See the same base? When you have the same base, you always take the bigger power. So LCD is the bigger power. Your base could be x, could be y, could be x plus y, could be anything. If you have the same base with multiple powers, the highest power is LCD. Because you can divide the highest power by all the lower powers. Now is it clear how do you find LCD? Any question? Madison, where did you get lost? Which example? Okay, let's start here. Can you multiply x by something and to turn into x plus 2? That means the LCD is their product. That's supposed to. If you cannot multiply something by anything and get the second one, it means the LCD is both of them. Just like 2 and 3. We cannot multiply 2 by something and get 3. That's why the LCD is their product 6. On the other hand, this is 2 and 4. You can multiply 2 by 2 and get 4. So LCD is the bigger one, 4. Same thing here. X cannot be multiplied by something to get x plus 2. So LCD is their product. Same thing here. If x plus y, you cannot multiply this by anything and it will turn into x minus 1. Because they are unlimited. LCD is least common, let's say LCM. LCM is the least common multiple. If you say looking for something big, that B is divisible by all 3. So between x and x squared, which one is big? Between x squared and x cubed, which one is big? And between x squared and x cubed, which one is big? That concept follows this one. X plus y, one of them. X plus y, 2 of them. Which one is bigger? 2 of them. So LCD is the 2 of them. Yeah. Now let's do some real math with the knowledge we just learned. Subtract 6ab minus 5b divided by 3. Between b and 3, what is our LCD? Only b or 3b? Because they are completely unrelated. So you take their product. So let me rewrite. 6c over b minus 5b over 3. We know we want to have 3b under both denominator. So how can you convert b into 3b? Multiply by 3. But remember, equivalent expression. If you multiply the denominator, you also have to multiply the numerator. So 6 over b turns into 18a over 3b. And now we have 3 here, but we want the LCD 3b. How can it turn 3 into 3b? From b. Multiply by b. And you have to multiply top and bottom. Once you have the same denominator, it's just like the first examples we did. Same denominator means keep the denominator once. Go ahead, send this. Remember the first thing we did, equivalent expression. Once you multiply one place, you have to multiply the other place with the same, otherwise they're not equivalent. So we need B here definitely because that's our LGD. But in order to be, in order to have equivalent expression, we also need to multiply the numerator. So what do you have on the first numerator? 18a, and the second numerator?
5b squared.
5b squared. Can you factor out anything here?
No.
So you're done. If you can factor, you're done. If you cannot factor, you're done. But if you can factor, you have to keep going.
Yeah.
What's the LCD?
The third. What did the x for the third?
You multiply if they have nothing in common. If one is not multiples of another one. Can you multiply x by something, it will turn into x squared? See, it's possible. That means you take the bigger one. X cubed is a multiple, but it's not the least multiple. We are looking for the least multiple, the smallest multiple. So we want x squared on both denominators. Does the first denominator have x squared? What can you do so that x turns into x squared? Times x. So you multiply both top and bottom. How about the second denominator? Do you already have x squared there? Do you need to do anything there on the second denominator? Great. That means it's time to combine our numerators. So 5x and 6. Can you simplify factor? So we leave them alone. Easy, right? Not bad. So I have an extra page. So let me. Okay, try the next one. Ah. I guess done with the left page. Not yet. Okay, never mind. What's the LCD between x and x minus 6? If you're confused, if you ask yourself, can you multiply x by something and it turns into x minus 6? Is it possible? No. Since this is not possible, that means LCD is their products. X times x minus 6. If one is not a multiple of the other one, the result is their product. So we have 2 over x plus 9 over x minus 6. And we just learned our LCD is their product. How do you convert x into x and x minus 6? Multiply by x minus 6. Here to the equivalent, you multiply by top and bottom.
X squared by 6.
Don't you have the same thing here? X squared minus 6x.
That would be since we have
So we are given x only, but we want x and x minus 6. Because this is our LCD. X and x minus 6. So what we don't have on the first denominator?
minus 6.
No, x minus 6.
Yes.
So you multiply top and bottom by x minus 6.
Okay.
What we don't have on the second denominator?
So we always put the LCD on.
So you put the LCD on the denominator because you have to write it once. And then you compare what you don't have in the given denominators.
Will you multiply
Times x. So we multiply both top and bottom by x. In multiplication, the order doesn't matter. 2 times 3 is same as 3 times 2. Now, do you have the same denominator on both denominators? That means it's time to combine the numerators. So what do you want the first numerator? Minus 12. And we are adding the second numerator, 9x. We have two terms here, right? So we have to distribute. And then we have one term here, so we just bring it down. And then do you see any like terms on the numerator? 2x and 9x, how many you get? 11x minus 12 x minus. Can you factor out anything from the numerator? So you're done. Now in the finalized, we will have one of these, at least one of these. Let's do one more together and then you have two to do by yourself. Can you multiply x plus 6 by something and it will turn into x minus 4? Good. So what is the LCD? Their product. X plus 6 times x minus 4. So let me rewrite. Now our LCD is x plus 6, x minus 4. So we want the same thing on both denominators.
3 times 1 side by x plus 6.
The first denominator you multiply by what? X minus 4. Both numerator and denominator. And what do you multiply the other side?
Minus x plus 6.
X plus 6. Now do you have the same denominator? So we go and do combining numerators. So we do following. What do you get? Then we go this way. Negative 4x, negative 5x, plus 20. And then we are subtracting. So when you subtract, what happens to the sign on the numerator? It changed. So the plus will turn into minus. So you have minus and minus. What do you have here? 7 times x and 7 times 6. 7 times 5, 35. It's 42. So for addition, we don't worry about changing sign, but for subtraction, be very careful. You always have to change sign. X plus 6, x minus 4. Do we have any like terms to combine on the top? Yeah. 4x, 5x, and then 7x. So combining all of them, how many x's we have? Negative how many? Negative 4 times negative 5 is? Negative 9 minus 7 is? When a time you are combining? Oh, it's negative. 16. So we have negative 16x. There is no more x squared term. And do you have any other like terms of the numerator? Plus 20 and negative 42. So what do you have? Positive or negative? Negative. If you're confused, we have 42 and 20. When you subtract, it's 2, 2. But 42 is a minus, 20 is a plus, so it's minus 22. Can you factor the numerator? Yeah. So 22 has either 122 or 211. Is any of the combination give us 16? So is the numerator factorable? That means we are done.
Yeah.
Any question? Was any step unclear, confusing, anything? Robert, practice a lot, huh? Negative 7x. So we are subtracting 7 times x plus 6, right? It's x plus 6 because of the numerator, the denominator x plus 6 is missing. So you're multiplying with top and bottom. So if this seems unclear to you, you can write one more line here. Negative 7 x plus 6. This is what you have. We are subtracting 7 times x plus 6. What is 7 times x? Negative 7x. What is negative 7 times 6? Negative 42. Try the next one. And there is one more. So finish this. Let's give your exam back.
ver na próxima classe, não era?
I don't have the reflection. You're not getting your exam back?
The reflection we do for that kind of. That's a go. I don't. Right? Yeah. Oh, do I give you the reflection as class?
Yeah.
Okay. Thank you.
So I don't have the reflection today. You also doing it? But I'm going to give you reflection tomorrow.
Oh, I know. Did you get grade? Did you get perfect? Then don't come from. Oh, that's right. Oh, all right. My second time in five, I still want to take it. Me too.
And then
Otherwise, so
one
what?
plus.
I never find out, but I
Other
never
following
my
question,
question.
but that's probably more than one question.
When I find this out. I think about it. Spare me. I think that's my.
No, it's mine, the last one. I swear mine's the last one in the stack.
Melrose, Giselle, huh? What did you write?
You took off like the rule that you don't have to.
Giselle. Give me one second.
It's like, what? So you was not a class. The class, like.
Sandy, Maria, Hassan,
I don't know, it's like.
Christina, Madison, Orlando, Stephanie.
Yeah. I try to go.
You really views.
And I'm like, feels fucking.
I know.
I'm just saying.
Fine, like, really? Sassy, Madison,
Don't ask.
Oh, yeah.
Don't even ask. It's not good. How did you do?
Joey.
Okay, that's good. I'm happy.
Oh,
That's hard.
Robert.
Tomorrow's Wednesday. How can the review? Isn't it? This one is last. I don't even want to try that last problem. It's not the case. It has a trip since last year. I think it's good. But I was above that.
Why is class
So if I have a class with me, I'm celebrating.
That's why.
Melville?
Yo, maybe not.
Listen, shut up. I know this is I would have dropped mine.
So you feel out for the second job? So maybe
Actually, I didn't. I'm not gonna get it back. So. Ella quiere, mire. Oh, it's full time. I'm back to
Oh, Jill. Maybe I know.
Oh, was it? Oh, I'm so sorry. I didn't know that.
Because he jumped in so
Yeah,
That's why I told you jumping. Because it's normal, not jumping.
This is without the 2 points or with?
We said it's 1 point. Without the 1 point.
Without? Oh, without.
I'm going to give you the selection of basket. If you allow it, you get 1 point.
Oh, okay, so when we're going. The thing you were said the training was first day, so it's there had this one. No, this one I had the original. Okay, so
the question I got.
Oh, mommy. Turn off this. Otherwise, you keep reloading.
I think I did much better in my exam than I